welcome back to Math 1720. We are in Chapter 5. We're starting Section 4. We're going to go over the sum and difference identities for sine and tangent. Just like in 5.3, we went over the sum and difference identities for cosine. Some similarities as we go through this. Okay, we can use cosine sum and difference identities to derive sine and cosine, or sine and tangent. Okay, so this is just a background methodology behind it. Alright, just some proofs on how we get to the identities. So we could start off by saying, alright, sine and cosine, we know that they're cofunctions. So I can start with sine of a plus b, rewrite it as its cofunction of cosine, and say 90 minus the argument of a plus b. Alright, and I can rewrite that and distribute that negative through. So we distribute the negative to a and the negative to b. It's actually the minus, right? But we treat it as a negative. So that ends up being, all right, cosine of the argument of 90 minus a times cosine b plus sine of 90 minus a times sine of b. We are just applying the cosine difference identity that we learned in the last section. Okay, that's all we're doing right there, where we're treating 90 minus a as an entire angle there. Okay, so we can go ahead and rewrite this now, and we can replace the cosine pieces of the 90 minus a and the sine of 90 minus a. So remember, cosine of 90 minus a is just the cofunction of sine of a. So that's why on the left hand side we rewrite cosine of 90 degrees minus a as sine of a. We don't rewrite the cosine of b. Okay, plus we can rewrite sine of 90 minus a, okay, using a cofunction identity. Sine of 90 minus a is equal to cosine of a because of cofunction. Alright, so this is where we get the entire function of sine of a cosine of b plus cosine of a sine of b. So we've used the difference identity for cosine and the cofunction identities to rewrite sine of a plus b as sine of a cosine of b plus cosine a sine b. Alright, so we can also do the same, alright, to get sine of a minus b. Not really going to go through the math on that one. You can kind of see how it works out there with the negative angle identities. But I want you to make sure that you write these two down. These are important. So you have your trig identity sheet that you've been keeping track of. Last section we added cosine of a plus b and cosine of a minus b. Now you're going to add sine of a plus b, which is equal to sine of a cosine of b plus cosine of a sine of b. You're also going to have sine of a minus b. Alright, that's our difference for sine, which is equal to sine of a cosine of b minus cosine of a sine of b. Okay, so you can either memorize those or have those on your trig identity sheets to work through. Alright, next we're going to move on to tangent. Alright, and I'm not going to go through all the algebra on this one. I just want to be able to give you the sum and difference identity for tangent. But here is where it's developed. I'll show you the first few steps of the algebra piece behind it. I don't expect you to memorize this or work through it, but I do expect you to write the sum and difference identities for tangent on your trig identity sheet and be able to apply them. Alright, but this is where it comes from. If we have tangent of a plus b, we can rewrite tangent, right? The fundamental identity for tangent was tangent is sine over cosine, right? So if we had like sine of theta, or if we had tangent of theta, it was sine of theta over cosine of theta. So we can rewrite tangent of a plus b is equal to sine of a plus b over cosine of a plus b. And now that we know the sum for sine, the sum identity, and the sum identity for cosine, alright, we can rewrite these. Alright, and you can flip through the slides. There's going to be a bunch of algebra we're going to go through, okay, that I expect you to know, but I'm not going to make you do this proof, but I want you to know the fundamental identities, okay? Which are these two. We can find that the sum of tangent of A plus B is equal to tangent of A plus tangent of B divided by 1 minus tangent of A tangent of B. And then we have the difference identity for tangent. Tangent of A minus B is equal to tangent of A minus tangent of B divided by 1 plus tangent of A tangent of B. Okay, so these kind of follow suits with what we've been doing. Make sure that these are on your trig identity sheets. So now you should have the sum and difference for cosine, the sum and difference for sine, and the sum and difference for tangent. Alright, so let's go ahead and apply each one of these. We want to find the exact value of sine of 75. Okay? Remember, just like last section, we don't have, everything's easy for us if we have a 45, 45, 90 or a 30, 60, 90 triangle. So we want to try and break the value of the 75 into two different angles that meet the criteria for the angles that we know how to find, right? 45, 45, 90 or 30, 60, 90. So, you have a couple different ways that you can break this one up. But the easiest way for us is to choose 45 and 30. We know how to find sine of 45, right? It's a 1, 1 square root of 2 triangle. And we know how to find sine of 30, right? It's a 1 square root of 3, 2 triangle. So, based on everything we've been doing from, chapter 1 in the book, we're going to solve these. But first, we're going to take the 75, rewrite it as sine of 45 plus 30, and then that's our sine sum identity. So we're going to rewrite that as sine of 45 times cosine of 30. Remember, it's sine of A, cosine of B, plus cosine of A, sine of B. So we're going to end up writing the second part as plus cosine of 45, sine of 30. Then using your unit circle, or you guys, we've been working with these a lot. We should know what these triangles break down into. So we can replace sine of 45 with square root of 2 over 2. We can replace cosine of 30 with square root of 3 over 2. Plus cosine of 45 is square root of 2 over 2. And sine of 30 is 1/2. So, doing some basic algebra there. Square root of 3 times the square root of 2 is square root of 6. Alright, 2 times 2 is 4. Plus square root of 2 times 1 is square root of 2 over 4. And since they both have the same denominator, we can write them as one expression as square root of 6 plus square root of 2 over 4. Okay, so, very similar to what we did last section, so it's just methodical, alright, procedural. Choose the right angles, and then apply the right identity. And then make sure, I would have on the side, have your little triangle for a 1, 1 square root of 2, right? A 45, 45, 90 triangle sketched out. Have your triangle sketched out for a 30, 60, 90. Make sure that you know the radians for that as well, because, next example, we want to find the exact value of tangent of pi over 12. Okay, well, that might be one that you want to maybe put 7 pi over 12 into degrees first. So remember, do that by multiplying it by 180 over pi. Alright, so when you do that, okay, you end up getting a 105. And that breaks into a 60 and a 45 degree angle. So remember, 60 degrees in radians is pi over 3. Alright, and 45 is pi over 4. So we can rewrite tangent of 7 pi over 12 as tangent of A plus B, where A is pi over 3, B is pi over 4. Then we apply the tangent, sum identity. So we rewrite it as tangent of pi over 3 plus tangent of pi over 4 divided by 1 minus tangent of pi over 3 times tangent of pi over 4. Now we replace our tangent of pi over 3's and tangent of pi over 4's, with our trig that we got out of doing the unit circle, and our special triangles. All right, it can all apply there. And we simplify it down. So on top, we end up with square root of 3 plus 1. In the denominator, we get 1 minus square root of 3 times 1. Okay, because remember, tangent of pi over 4 is what? Opposite over adjacent, which is 1 over 1, which is 1. All right, and tangent of pi over 3, or yes, pi over 3 is square root of 3 over 1. So we've replaced those, okay, and working through the algebra. We have to use a common denominator. This is a very important example for you to write down. You're going to multiply by the conjugate. Okay, the conjugate, remember, is the same thing with the opposite sign. So in the denominator, the original denominator is 1 minus the square root of 3. The conjugate of that is 1 plus the square root of 3. So we're going to multiply the numerator and the denominator by 1 plus square root of 3 over 1 plus square root of 3. Because we're really multiplying by 1, but just in a form. Why are we doing that? Because we need to get the radical out of the denominator. We can't have a final answer. And this is a method of quote-unquote rationalizing the denominator, essentially. We're going to multiply by the conjugate. So very important when we do that. So remember, when we multiply by the conjugate, okay, certain terms drop out in the denominator. So that's what makes it easy for us. In the numerator, okay, you need to, all right, multiply all of those out. So that's going to be your FOIL method or your box method, right? You're multiplying two binomials. So the quantity of square root of 3 plus 1 times the quantity of 1 plus square root of 3. So when we do that, we get square root of 3 plus 1 plus the square root of 3 all over on the denominator. When you FOIL that out, or box method, however you want to multiply your binomials, you end up with 1 minus the square root, or 1 minus 3, sorry. And then a little bit more simplification, we end up getting 4 plus 2 roots of 3, all divided by negative 2. So we could break that up as 4 over negative 2 plus 2 square root of 3 over negative 2. And that would help us simplify it down a little bit more. All right, because since they have a common denominator, we can break them into two fractions. So 4 divided by negative 2 is negative 2. All right, and then the negative 2 in the denominator and positive 2 in the numerator cancel. So we end up getting negative 2 minus square root of 3. So just simplifying that down. And the reason we chose that, right, is because 4 is divisible by negative 2, so is 2. So we rewrote it as two separate fractions and simplified it on down. Alright, now we want to find the exact value of sine of 40 cosine of 160 minus cosine of 40 sine of 160. Take a look at your trig sheet. Which identity should we use here? Okay, that's what I really want you to start thinking about. Which trig identity? You know, obviously, since we've got a mixture of sine and cosine, it's going to be the, you know, either the sine sum or the sine difference identity. We can see that angle A has got to be 40 and angle B has to be 160. Okay, so we can rewrite that in the sine difference identity. So that turns us into sine of 40 minus 160. Okay, that's what our argument's going to be. So we're just rewriting that using the sine difference identity. So make sure that you see how we're doing that on your trig identity sheet. Angle A is 40, angle B is represented by 160. So now we have 40 minus 160. All right, so we end up getting sine of negative 120. Okay, now we can use the identities. Okay, look back on your sheet. Since we have sine, remember we have like sine of negative theta equals negative sine of theta. Okay, so we can apply that here. So we end up with negative sine of 120. And we should know, right, 120 is in the the second quadrant. Okay, but remember we're going the opposite way now. So we're going to actually end up in the third because of the negative out in front of sine. So sine, or 120, is represented as square root of 3 over 2, right? Draw your reference triangle. You're using a reference angle of 60 in that case. And so it's a square root of 3, 1, 2 triangle. All right, so you end up with negative square root of 3 over 2. You should be able to do that pretty easily. We did a lot of that in chapter 1. Alright, let's see how well we know this now. On the next example here, we want to write each function as an expression involving functions of theta. Okay, so these ones get a little bit more involved, right, because now we don't have two angles. We have one given angle, A, and then we have our B is actually a theta. So we're going to write everything in terms of theta. Generally, we're going to have some things that fall out here. So that looks like what? We're looking at the first one. We have a cosine of 30 plus theta. That looks like our cosine sum identity. So we rewrite that as cosine of 30 cosine of theta minus sine of 30 sine of theta. So make sure you're looking at your trig identity sheet. We need to be able to write cosine of 30. What is that going to be? Okay. And then we want to be able to write sine of 30 as well. So we can rewrite cosine of 30 as square root of 3 over 2 times cosine of theta minus sine of 30 we rewrite as 1/2. Alright, and then we end up with sine of theta. So we've rewritten that function in terms of theta. We can't really go too much further other than doing some simplification here and writing it over one common denominator. It's really the only thing we've got left there because we don't know the value of theta. But we've simplified that equation in terms of theta. Alright, let's take a look at the next example here. That's our tangent difference identity. So we have tangent of 45 minus theta. So we apply it to our tangent difference identity. So look at your trig identity sheet and replace A with 45 and B with theta. So we end up with tangent of 45 minus tangent of theta all over 1 plus tangent of 45 tangent of theta. We should recognize that a 45 degrees is a 1 square root of 2 triangle. So opposite over adjacent, 1 over 1 is 1. Okay, so we end up with 1 minus tangent of theta divided by 1 plus tangent of theta. Okay, we don't need to simplify that one down anymore just because you don't do it in, it's not a sine, it's not a cosine, there's no squared on it. That's about as simple as we're going to get. Okay, now let's look at the next one. We got sine of 180 minus theta. That's our sine difference identity. So A is 180, B is theta. Alright, so we rewrite that as sine of 180 times cosine of theta minus cosine of 180 sine of theta. We should know that sine of 180 degrees is what? It's going to be 0. Okay, cosine of 180 is -1. So that little box, I'm sorry that it's showing that, means to multiply there. So 0 times cosine of theta is 0. And then we have minus a minus, or minus the opposite, that becomes a plus. So our final answer is just sine of theta. Alright, moving on to the next example here. We want to suppose that A and B are angles in a standard position. Alright, with sine of A is 4 over 5, and it's telling us that A has to be between pi over 2 and pi. Well, that's because it's a second quadrant angle, right? That means we're going between 90 and 180, pi over 2 and pi. Alright, it's a second quadrant angle, so sine is going to be positive there, so sine of A is 4/5, which is good. Alright, then it says we're going to use cosine of B, and B has to be between pi and 3 pi over 2, so that puts us in the third quadrant there, so cosine does have to be negative. Alright, so the third quadrant, because we're going to be between 180 and 270 if we're looking at degrees. So we want to find each of the following here. So we got the restrictions on A and B. Now, some hard parts in the approach that you need to take to this problem is we're given sine of A and we're given cosine of B. In order for us to solve this, you're going to have to make a triangle using sine of A equals 4/5, and you're going to have to make a triangle using cosine of B equals -5/13, and you're going to have to draw them in the correct quadrants. Why do we need to do that? Because we're going to have to know what sine of A is and cosine of A is. We're going to have to know what sine of B and cosine of B. So we're going to have to use what we're given, right, to find the other trig function of that angle. Okay, so first example, part A. We're going to find sine of A plus B. Alright, well, we're going to rewrite that as our sine sum identity, but we don't know what cosine of A is, and we don't know what sine of B is. So we have to draw our reference angles and find those. Okay, so we can do that, or if you remember, we can also use the identities. Okay, sometimes it's quicker and easier to use our Pythagorean identity. We know what sine is, right? Sine was given to us as 4/5. That's back here on this slide. So I can substitute in and say 4/5 squared, okay, plus cosine squared is equal to 1. So I can get 16/25. 1 minus 16/25 is 9/25. Then I square root both sides, alright, and I get plus or minus 3/5. I have to choose negative 3/5 because cosine is negative in the second quadrant. So I will choose the negative 3/5. So now I have sine of A, which was given to me. I have found cosine of A. Okay, we were given the other angle. So we have to find sine of B because we were given cosine of B. So we can substitute that into the Pythagorean as well. So we're going to get sine squared of B plus negative 5/13 squared equals 1. So when I square that, I'm going to get 25/169. Alright, and then we have to do 1 minus 25/169, and we get 144/169. Then that's equal to sine squared. I'm going to take the square root of both sides. When I do that, I get plus or minus the square root of 12/13, and we are looking at B. B is a third quadrant angle. The sine value has to be negative there. So sine of B is negative 12/13. Okay, so two ways you can find that angle. One, for both of these, right? You could have drawn your triangle in their respective quadrant, in quadrant 2 and quadrant 3, found the reference angle, and then found the value for cosine of A and sine of B. Or you could do what we just walked through using the Pythagorean identity, alright, to solve for sine of B and cosine of A. Now that we have both of those, we're still not done with part A of the example here, okay? Now that we have both of those values, we can apply them to the original portion of our problem where we have our sine sum or our sine difference, okay? Now, we also need to be able to find tangent of A, and we can use sine of A over cosine of A to get us tangent of A. We've calculated sine of A, or sine of A, yes, and cosine of A. One of those was given. We substitute those in. We do the same with B. Alright, we take sine of B over cosine of B. Alright, do the algebra or do the fraction work, right? And we get the value. So now we have everything we need. So going back to example A, we have sine of A plus B. So we're going to put in the values we just calculated for sine of A, cosine of B plus cosine of A, sine of B. Remember, that's your sine sum identity that comes off your trig identity sheet. Alright, so we just substitute in the values we had, and it's literally just in quick and easy simplifying fractions down from there. Okay, so when you end up doing all the work, getting the common denominator, okay, that common denominator is obviously 5 times 13 when you do that. Alright, and we end up getting 16/65. Okay, for part B, we substitute in all of our given values that we just worked through, and we end up with 16/63. Okay, I'm not going to spend a lot of time going through fractions. You guys should be able to solve all those. And then we want to find from parts A and B, alright, when sine of A plus B is greater than 0 and tangent of A plus B is greater than 0. The only quadrant, okay, which both of the values are positive is quadrant 1. So A plus B has to be in quadrant 1. Okay? Alright, last example here. We want to verify the equation is indeed an identity. So we have sine of pi over 6 plus theta plus cosine of pi over 3 plus theta. Can and will that be simplified down to cosine of theta? If we just look at this problem for a minute, we have sine of a plus b. Alright, and we have a cosine of a plus b. So we need to think about, we're going to use the sine sum identity and the cosine sum identity to solve this. Alright, so just think about that. See, the a's don't have to be the same. This is sine of a plus b. So if we're looking at the first half of the equation, a is pi over 6, b is theta. Then if we look at the second part of the equation, pi over 3 is our new a, theta is our new b. So we need to be able to apply the sine sum identity and the cosine sum identity here at the same time. So when we do that, we end up getting sine of pi over 6 cosine of theta plus sine of theta cosine of pi over 6 plus, alright, cosine of pi over 3 cosine of theta minus sine of pi over 3 sine of theta. So we can use pi over 6, which is a 30-degree angle for us, and we know how to rewrite pi over 6 or sine of pi over 6, and then we can use pi over 3, which is our 60-degree angle. So using our 30, 60, 90 triangle, alright, we can replace sine of pi over 6 with 1/2, and we can replace cosine of pi over 6 with square root of 3 over 2. We can replace cosine of pi over 3 with 1/2, and we can replace sine of pi over 3 with negative square root of 3 over 2, okay? Or just with square root of 3 over 2, that was already subtraction from the cosine sum identity. Now, we can simplify some terms, alright? We have a half a cosine of theta and we have a half a cosine of theta. Alright, we can combine those and we have a square root of 3 over 2 sine theta and we have a minus square root of 3 over 2 sine theta. Those two terms are going to cancel. Alright, so all we're left with really is the half cosine plus the half cosine. Well, a half plus a half is 1. So essentially our last step ends up giving us cosine of theta. Okay, well, that's the end of this section. If you have any questions, feel free to email me or ask me in class. This one should take you a little bit of time to work through the problems, but the biggest thing for you is have your trig identity sheet next to you so that you at least can get through the rewriting piece, you know, when breaking it down to the angles that you know, 30, 60, 90, 45, 45, 90, so on and so forth. Alright guys, take care. We'll see you in class.